Awesome. Hi, folks. My name is Matt. I'm a program manager in AI Search. And today I'm actually here to talk to you about RAG with AI Search and dotnet. So today's talk is really going to be about how do I build an AI chat app that uses the RAG approach to combine an LLM with your own data. A lot of terms here, so let's kind of go through what we're talking about. Let's start with the term LLMs. So LLMs are large language models. They are models that are so large that they've actually achieved general purpose language understanding and generation. The general way we use language models today is through a task called completions. So it's best explained through an example. If I tell an LLM such as ChatGPT, hey, I have a task for you. It's called sentiment analysis for movie reviews. Hey, the movie's not good. That's a negative review. If I then tell you I love the movie, what's the sentiment? And the LLM is going to go and actually kind of complete that text and basically say positive. So it looks at the previous text and it actually predicts the most likely next, they call it tokens, which is kind of how LLMs view units of text or words. And you can see that LLMs have really gotten a lot better at this task over time. In general, larger language models perform much better at these tasks, as the graph is illustrating on the right. So there's a lot of language models in use today. Some of the most common ones we're just going to go over really quickly. We've got GPT 3.5 and 4. You may or may not have heard of these. These are from a company called OpenAI. You can use them in Microsoft through Azure OpenAI. They've got lots of use cases. They power the ChatGPT experience. They power various copilots, and there's lots of programmatic ways to use it through an API. Other companies, they've also produced their own language models such as Palm, Claude 2, Llama, and Mistral. Those are some other names that might come up. So we typically, when we use the Azure OpenAI APIs, the LLM that we are using is based on an architecture called GPT, which is Generative Pre-trained Transformer. This is based on a very foundational and famous paper called Attention is All You Need. It was actually released a couple of years ago. It took a while for this paper to really kind of be put in production and produce the language models that we know and love today. This is a really interesting topic. We won't have time in this talk to go into it, but if you're interested, I encourage you to check out the links. A researcher at OpenAI, Andres Karpathy, has produced two really useful videos. One is State of GPT, and another is Let's Build GPT from Scratch and Code. So if you're interested in learning about the inner workings of language models, I highly recommend these. The visualization on the right-hand side really shows you how the foundation of next token or just kind of unit of text prediction is working here, where you've basically got a sentence, the animal didn't cross the street because it was too tired. How there's this mechanism called attention, which actually is able to accurately predict the most likely next unit of text based on what's come before. So if you're curious about this, feel free to check out these resources. So let's just dive right into the code. Basically, if I am a .NET developer and I want to use this GPT model in my code, how do I do that? Well, we actually provide a NuGet package for Azure OpenAI, and we provide another NuGet package called Azure Identity for actually authenticating. So what I do is once I've deployed my Azure OpenAI service, I can actually connect to it in .NET code using an Azure OpenAI client. I'm using a concept here called default Azure credential, which really takes the guesswork out of credentials. Whereas in the past, you might have had to worry about things like API keys. How do I deploy them securely? How do I rotate them? Default Azure credential really eliminates all that guesswork. Instead of using an API key, I use my identity. So I, Matt, have a user identity associated with my Azure subscription, and I can actually use that identity to authenticate to Azure OpenAI rather than using keys. If I deploy my code in a service like Azure Functions, I can actually use either user-assigned or system-assigned managed identity to stand in for my personal identity without changing any of my code. So we really recommend checking out default Azure credential and using it wherever you're authenticating the Azure services, not just AI ones. I then create a service called the chat client. I just specify the name of the deployment, which is basically just saying, hey, I want to use the latest and greatest GPT-4o, which is GPT-4 Omni. I want to use that in my code. So I basically get a chat client for that. I then, going back, I talked about completions. I basically write all the text that has happened in the conversation. In my case, hey, your helpful assistant, I want you to talk like a pirate. Then I am telling it, just Azure OpenAI support custom managed keys. And when I actually run this code, I get pirate themed text that says, yeah, it does support custom managed keys, and here's how to use it. Language models are great. Unfortunately, they have two key limitations that makes them very difficult to use in many production applications. So number one is outdated public knowledge. I ran a sample app. I just got some kind of response. We asked you two questions. Write a model class using the latest version of Entity Framework, and it's not quite getting it. It's using an outdated version. That's because language models like ChatGPT are trained up to a certain point in time. They do get retrained occasionally, but they're not refreshed nearly enough to know anything about what's happening on the internet yesterday, for example. They also don't know anything about your organization or company. So when I ask the question, does my company perks cover underwater activities? It just has no idea. It just gives me a generic answer asking me to contact HR. This is still a good answer because it's recognizing that it doesn't know, but we're looking for something a little bit more. We would like to add our private knowledge so that we can make our application built using LLMs even more useful. So there's a couple ways when we think about incorporating domain knowledge into our app. There's three general strategies we can use. Number one is prompt engineering. So when I write my system prompt, hey, talk like a pirate, if I go back a couple slides, I could actually kind of put some user knowledge in there. I could say, hey, by the way, my company perks do cover underwater activities. So when somebody asks you that, give me the answer, yes. This is obviously a bunch of limitations. The number one being you're kind of limited by your prompt size. You also have to be pretty good at authoring prompts, which can be tricky. Fine tuning basically is kind of resuming the training of a language model and basically training it on your documents. This can be successful, but it can be really tricky to get right, and it can get really expensive. This is generally not the first tool in the toolbox you reach for when you think about incorporating domain knowledge into your application. Finally, we have Retrieval Augmented Generation. This is what we're going to be talking about today. This is essentially pairing the language model with a retriever. So when I ask the question, do my company perks cover underwater activities? I actually go and search for the answer in some kind of retrieval database. We're going to be talking about AI search today. AI search is on Azure. It is a vector database combined with traditional text search application. And what you can do is you can basically use this to power all your language model apps to kind of get all this internal knowledge that they otherwise wouldn't have. You would have to either retrain the model or you would have to kind of do something else to get that knowledge in. Azure AI search really allows you to connect the language model with your data pretty seamlessly. We don't worry too much about kind of changing the language model itself. Basically, the user asks a question. We use that question as a search query. We retrieve some documents. We then pass those documents to the language model, and we use those documents to answer the question. This is a really powerful pattern. It is actually really easy to implement. And today we're going to be covering this dotnet sample that actually implements it for you. And it just opens up all kinds of interesting and exciting applications you can do with language models now that you can actually connect it with your data. So going back to our two questions we asked earlier, I was actually able to deploy our sample application, which I'm going to show you in a second, but we're just going to look at some answers. So now when I ask it the question, what are the latest changes to Entity Framework? I actually kind of grabbed some Microsoft documentation on some breaking changes from EF Core 8, and I was actually able to get a really good answer, basically say, hey, when I update from EF Core 7 to 8, here are all the breaking changes. This is not a question you would be able to ask a public LLM unless it's been trained more recently and has kind of seen that document. But you can very easily just add a new document to your search database and get better answers. I can also kind of ingest my company's HR documentation. We've got some sample HR documents included with the sample. And so when I ask, do my company perks cover underwater activities? I get a very definitive yes. I also, very importantly, get a citation. So I don't have to take the language model's word for it. So when I go to my chat and I ask a question like, what is included in my Northwind Health Plus plan that's not in standard? We're going to generate an answer, but we're not just going to get the answer itself. We're actually going to get a citation so I can verify it. This is really important because sometimes language models undergo something called hallucination, where they make up facts that sound plausible, but they're just completely made up. Because we have the citation and we can open it, we can say, hey, what do my plans actually cover? What is the comparison? So I can actually read the text that the language model is using to answer the question. So this kind of provides an extra degree of certainty and confidence when we're using retrieval augmented generation. Here. So we're going to talk about a couple components we need to build a retrieval augmented generation app. First thing we need is a retriever, right? It's this search database, this knowledge base that can really efficiently retrieve sources that match a user query. We're going to use a bunch of techniques to do this, namely something that has come up recently is called vector search, where rather than just searching the verbatim text, we're going to use another machine learning model to actually take that text and translate it into an embedding, which is basically just a giant list of numbers. And we're going to compare that list of numbers with every other list of numbers in the database that corresponds to documents we have to find a good match. We combine that with full text retrieval to get the best possible results. So retrievers are really important, and there's a lot that goes into it, but just using AI search out of the box gets you the best results. Language models, these are what we talked about earlier. They're the actual models that answer the questions and include citations. We typically use GPT 3.5 and 4. As I mentioned earlier in the presentation, we have, okay, thanks. As I mentioned earlier in the presentation, we use GPT 4.0. This is a more modern version of GPT 4. It's also much more cost efficient than GPT 4. So we recommend if you're going to be experimenting with these models, GPT 4.0 is definitely should be in that list. We've got some glue, which is how we actually connect the retriever to the LLM. There's a lot of frameworks that do this. In the sample we have for you today, we use Semantic Kernel, which is a framework from Microsoft for kind of just defining applications that use the RAG pattern. There's a lot of kind of common code components that it abstracts away from you. You don't need to worry about implementing them yourself. Finally, we've got like a variety of features in our app. This one I really like because there's actually a upload documents tab. So I can actually see what documents I've uploaded to the app, and I can actually select new documents from my computer. So I can actually re-upload this entity framework core breaking changes PDF and kind of refresh the knowledge. I'm not going to do that right now because it takes some time, but it just shows you that like all these different retrieval augmented generation apps can have lots of features. And which features you support, it just depends on the scenario you're working on. So our solution today, we're going to use Azure AI Search as the retriever. We're going to use GPT 3.5 or 4 or 4.0 as our language model. And we've got a couple interesting features. I showed you the upload your own document screen, but it also supports voice chat and what we call multi-turn chat. What does that mean? Well, multi-turn chat basically just means I can keep talking to it after it answers my question. So rather than just asking it a single question, I can ask it follow-up questions like, hey, what's the cost difference between Northwind Health Plus and Northwind Standard? And it will try to find the answer for that. It gives a kind of vague answer here because, again, the specific cost difference is not in the documents we uploaded. So the link below is kind of a link to our demo, so you can actually browse the source code yourself. We're going to dive into the source code a bit later. So let's do that right now. Let's go looking at the prerequisites for deploying our solution. You need an Azure account and subscription. You can use a free account. It will have limitations because, unfortunately, some of the components in the solution do have a cost associated with them. We're going to be deploying things like container apps, Azure OpenAI, and billing for Azure OpenAI works in terms of these kind of like minimal text units to make up a sentence. So if you remember earlier in the presentation, we talked about, hey, the animal didn't do this. Well, you can break up that text into these things called tokens. And the way Azure OpenAI billing works is you're billed for every single token that you use. You do need access to Azure OpenAI or an OpenAI.com account. This solution supports both the Azure OpenAI and the OpenAI model deployments. And finally, you're going to need permission in your Azure subscription to actually create new deployments and role assignments. This sample does not use keys. It uses role-based authentication, so that default Azure credential we used earlier is going to work. And we can dive. You can dive into the requirements on this link. So there's three different ways you can open this project. Number one, you can use this feature in GitHub called Codespaces. Codespaces is probably the easiest way to get started because you just need a browser. Once you open a Codespace, all the requirements for the project are automatically installed for you, and you can just start working on it. It's definitely a very easy way to get introduced to code. You can also use VS Code with Dev Containers extension, which is very similar to Codespaces, but the difference is it's running on your local machine. So if you have VS Code, this is a good option. And finally, if you don't want to use either of those, you can just set up a traditional local environment. This does require installing a bunch of dependencies that are automatically set up for you with either Codespaces or VS Code. Deployment of the sample is made super simple using the Azure Developer CLI. You just need to do three commands. Number one, you log in. You log in to your Entra tenant using azd auth login. The use device code parameter is important because if you're logging in Codespaces, I'm actually going to use the device code flow. If you've ever authenticated to anything on your TV or a IoT device, you've probably used this, where you basically get a code and then you log in and you paste that code in your web browser and your device is set up. You then create what's called an AZD environment, which basically all the parameters for deployment. Hey, what Azure OpenAI account am I using? What AI search service am I using? These are all tracked by the AZD environment. And then finally, you run the AZD up command, which provisions everything and deploys your code, and it's ready to go. So AZD really takes all the guesswork out of setting up your deployment. You don't need to click around in the portal. You don't need to read and understand how everything works. You can just run these three commands. If you have any existing resources, you can use them. If not, you can provision everything from scratch. So this is really the easiest way to get started with deployments. So let's spend a little bit more time looking at the app. So we're going to see here, there's a bunch of different components. Basically, when we deploy the app, we've got all these tabs. This is just kind of the home screen. We have the voice chat mode. We have uploading documents, and we have chat. So I can do any one of these features. We're actually talking with a container app. A container app in Azure is basically just kind of zipping up all your dependencies into a thing called a container, which is, think of it as a VM within the VM. It's basically a really easy way to package up all the dependencies into a single deployment and deploy consistently anywhere. Sometimes it can be kind of challenging working directly with VMs, so containers make it even easier to deploy these kinds of apps. You also get a link directly back in the app, directly back to the source code. So we'll go over the high-level structure here. There's a couple folders here. App is where all the app code lives. Data is where I mentioned that it comes with some HR documents. These documents are available here, so you can look at them at GitHub. Rather than just relying on a citation viewer. Docs is just photos for the documentation. Infra is an interesting folder. So I talked about AZD automating deployments. We use a language called Bicep. If you ever heard of ARM templates, Bicep is a friendlier way of creating those. It's basically a programming language that lets you deploy things to Azure. We've written all the Bicep for you, so when you run AZD up, it runs this Bicep to actually deploy the resources. So let's talk a bit about the application architecture. So how does the sample solution actually work? Well, we've got our upload UX. We use a Blazor app. Blazor is a UI framework. So when I deploy an ASP.NET app in .NET, Blazor is one way I can render pages. It goes to this container app. The container app performs React using, hey, I'm going to use search. I can upload documents using the upload documents tag. When I upload my documents, right? So I basically have a couple of components. I've got an Azure function. The function is very simple, but what it does is it uses a feature called blob triggers. Blob trigger, basically what it means is when I go and I upload, my file, what happens is the file gets put in a storage account, and the function runs every single time a blob is uploaded to the storage account. Once that function runs, what it does is it basically takes that blob and it makes it available for the, it basically uploads it to this storage account. That's really all the function does, but it makes it available to the search index. The search index is basically think of it almost like a database table. It has columns. So, hey, I have a document. It's got a source page. It's got a source file. It's got this list of numbers, this embedding. It's got the textual content. So once the function runs, it actually takes this document, which is a PDF, and it translates it into these fields that make it available for search. So I can basically say, hey, I want to refresh the entity core breaking changes. I'm going to go into my documents tab. I'm going to upload it. Okay, uploading it puts the blob in a container. The embedding function then runs because it uses a blob trigger, and then it makes it available to the search index, which basically has all the columns we need to do retrieval augmented generation. More code walkthrough. So I've done that a bit here. Let's talk a little bit about the actual chatting. So how does the chatting actually work? So what you really want to do is there's this reply async function where most of the RAG code lives. We're just going to go over really quickly. We've got some code here that refers to this thing called kernel. Kernel is semantic kernel. This is the glue we talked about earlier in the presentation, actually going to let us perform retrieval augmented generation. We fetch the question from the history. We're going to assume the last message. So like when I send a message to the chat, the last message to send is the question. And then we generate the answer based on that. The first thing we do actually is we rewrite that question. So we generate a search query using this completion functionality in the language model. So we basically say, hey, when I ask the question, what is included in my Northwind Health Plus plan, I generate a search query for that. So I generate a search query using this prompt. I then go to AI. So using AI search for retrieval augmented generation is simple as basically just calling this query documents async. If I get some no documents back, I'm going to assume no sources available. Then otherwise, I convert the documents to text. Remember that language models mostly operate on text. GPT-4o is multimodal, so it can support images. So if we are using image-based RAG, we will actually fetch the images as well. But once we get our supporting content, we will put it together into a single prompt. We use this just prompt, hey, you're a system assistant who helps the company employees with their questions, be briefing your answers. We give it the original user question, we give it the supporting content. And then finally, we actually answer the question. And what's really important is if we don't know the answer, we say we don't know. So once we do that, we just fire off that completion and we return it. And we get an answer like this, like Northwind Health Plus covers generic brand name specialty drugs. So what we've done here is we've taken something that's very complex to do previously before language models existed, which is natural language question answering. And we've literally made it as simple as, hey, use AI search to find some supporting documents and then use Azure OpenAI to complete some text. And we have natural language question answering built into your app. What's really interesting is how actually little code you need to write, especially if you use a framework like semantic kernel. So I encourage you to check out the sample and read it a bit more in depth. But really, that's the core of what we're doing here. Everything else is, for the most part, just kind of setting up the web app and other types of glue for other features. But really, this reply async method is kind of the core of the retrieval augmented generation loop. Let's head back. So let's talk before we continue. Like, let's finish and talk about the actual search approach. So when we talk about searching is hard to do well. We spent a lot of time in AI search making sure that you get really good out of the box results. We have a blog post, we call it RAG Relevance, Outperforming Vector Search with Hybrid Retrieval and Ranking Capabilities. Basically, what we did is we benchmarked a variety of retrieval methods on the Beer data set, which is a very common text data set used in academics. And what we found is that hybrid retrieval, which is basically combining vector and text-based search with AI search's semantic re-ranker, which is powered by a Bing deep learning model, gets the best results that you could possibly get. So check out this blog post if you want to learn more about the details of how the actual search works. But basically, by combining embedding-based search and keyword-based search, and then re-ranking the results using semantic re-ranker, which is an option available in the AI search, we get really good at supporting documents so that when we go to ask questions in RAG, if the documents are there, we'll be able to find them and answer the question. So that's about all I have time for today. We've got a lot of great content in the .NET Conf focus on AI. You can learn more at the following link. And please feel free to check out our other sessions. If you like this, feel free to look more in the sample code, read our blog posts about React relevance. And yeah, thank you so much for your time. I really enjoyed walking you through the sample, and enjoy the rest of the conference.